Good afternoon. I'm going to talk about climate change and greenhouse gas emissions from Canada and from Ontario. And I'm going to talk about an important sector in Ontario's economy, which is responsible for significant greenhouse gas emissions and how we can reduce these emissions. I assume the audience is familiar with the science of climate change and greenhouse gas emissions, the terminology, and the units of measurement of greenhouse gas emissions. Let's start by looking at the research report itself. This is an OSPE research report, which I put together with a great deal of assistance from OSPE people and many outside experts, dozens of interviews with experts in the transportation industry, academics, and non-government organizations. If you read the report itself, it shows the full list of persons interviewed. This report, Reducing Greenhouse Gas Emissions from Ontario Diesel Highway Trucks, is available, can be downloaded from the OSPE website. Start off with looking at Canada's greenhouse gas emissions. This is the official record from Environment Canada. It shows that Canada's greenhouse gas emissions have actually increased since 1990, when we started to show some worries about it. And they seem to have plateaued around 730 megatons of greenhouse gas carbon dioxide equivalent per year. And this is a source of concern to us in a world where global warming is starting to have some very serious consequences. Canada has declared a 2030 target of 40% lower than the 2005 total, which is down here around 420 megatons per year. And it looks as if we're nowhere near achieving that target. And we have to think very carefully what we're going to do in order to achieve this target. The other target that Canada announced quite recently is net zero emissions in the year 2050, which would put the line on the graph down here below this graph. And it doesn't seem as if we're heading in that direction. So we need to have some good ideas on how to reduce things quite significantly. And in the next few years, not in 15 or 20 years from now. So let's look at Ontario. Here are Ontario's greenhouse gas emissions. Since 1990, they did go up, then they came down when Ontario stopped burning coal to generate electricity. And also the Ontario economy changed quite significantly. We're not so much a smokestack economy anymore. The film industry now has more employees than the steel industry. We have a service-based, knowledge-based industry, not as much as of the smokestack industries as before. So there have been some reductions, but the transportation sector continues to increase in emissions, led largely by motor vehicles. We have to take a good hard look at how to reduce these emissions from motor vehicles in the future if we expect to bring our emissions down. Within the transportation sector, the most anxiety-inducing sector is trucks, long-distance diesel highway trucks. So that's why we're looking at trucks today. Why trucks? Let's look at the emissions from Ontario diesel highway trucks since 1990. Ontario freight truck emissions increased from 6,390 kilotons of carbon dioxide equivalent in 1990 to 12,700 in 2019, and that's a 99% increase. It's much bigger than Ontario's population rate of growth. It's, in fact, the tons per capita went up by 41% during this time. This is a serious concern to us. It's the sector with the highest rate of growth in greenhouse gas emissions in the entire Ontario economy. We need to consider significant reductions. Can we reach this target of 30% reduction by 2030 in this sector? Yes, we can if we adopt simple, practical changes to the pathways and equipment we use to deliver freight. Here are the targets again. Can we get down to just over 6,000 kilotons per year by 2030? Yes, it is possible. This data is from Canada's National Greenhouse Gas Inventory Report, which can be downloaded from our website. Now, the people that we interviewed for this report recommended significant reductions from practical, achievable actions and technologies, truck efficiency improvements, including streamlining of trucks and trailers, low rolling resistance tires, longer containers from 53 feet to 60 feet. That means you can pack more freight into the same truck with the same fuel consumption. Long combination vehicles, which once again, more freight on the left and the same fuel consumption. Other measures included driver training, almost unanimous recommendation for driver training to improve fuel efficiency. Organized planning of freight shipments. We can plan the shipment of every container of freight in a way that maximizes the efficiency of delivery, minimizes fuel consumption. Freight shipments could be planned the same way that airline passengers are planned. And there are other recommendations too. Off-peak delivery of freight can save about 5% in the greenhouse gas emissions per ton kilometer, and are now acceptable to Ontario's provincial government. And at the bottom of this list for simple, achievable measures, natural gas fuel. We already have the fuel, the technology, and the infrastructure to fuel highway trucks with natural gas over the next few years, more and more, as the older trucks are retired and new trucks are brought online. So this is quite optimistic and is described in great detail in the report. Okay, some facts we should keep in mind. Fuel savings, greenhouse gas emission reductions. It's that simple. Combustion of 1 liter of diesel fuel emits 2.73 kilograms of carbon dioxide into the atmosphere. Have to keep that in mind when we're looking at this situation. And some more data. Ontario has 135,000 highway diesel trucks, and in 2019 they burned 5.57 billion liters of diesel fuel. Fuel savings, greenhouse gas reductions, better planning and scheduling, fewer kilometers, fuel savings. At the top of our list for the trucks themselves is streamlining of trucks, reducing the drag coefficient of the truck. If you're not too sure about this term, drag coefficient, go back to your engineering textbooks and look up your fluid mechanics textbook. The drag coefficient is quite well explained. Okay, we'll start with the old truck, 100 kilometers per hour. Here's an older truck, not much streamlining there. 52% approximately of engine power is used to overcome aerodynamic drag, the force pushing back, the wind force pushing back on the vehicle as it tries to blast along at 100 kilometers per hour. Now this can be greatly improved with streamlining. Streamlining attachments can reduce aerodynamic drag by up to 26%. And you see in this more modern truck with the deflector dam on the top of the cab. These are gap reducing skirts, which reduce the drag induced by the gap between the truck and the trailer. This is a side skirt. You see more and more of these on long distance trucks, and they're slowly coming into use. And you will see other aerodynamic improvements over the next few years. It's not just a matter of helping the environment, it's also saving money for the trucker. Let's take a look at some futuristic truck designs. These do look pretty futuristic, and they look fantastic right now, but you will see these in the future. Just as automobiles became streamlined and more aerodynamic over the last 40 years, trucks will become streamlined and aerodynamic in the next 10, 15 years with lower drag coefficients. It will take some practical application before these devices are seen on most trucks. Here we see what's called a boat tail, which significantly reduces the turbulence and drag from the flat back of the truck. And these have been tested. Some of the drivers complained that they broke off when the drivers broke into the loading docks, but that's the sort of practical consideration that must be engineered out of these. And you will see them in the future. The big winner in reducing greenhouse gas emissions is intermodal transportation. If we can shift more freight from trucks to rail or even marine in Ontario, the greenhouse gas emissions will be much, much less. In the upper right of this slide, you see the typical greenhouse gas emissions in grams of carbon dioxide per ton kilometer for the three modes of transportation. Marine, only 8.1 grams, trucks, 65.6 grams. Maybe a disclaimer here, the marine emissions, they're probably for very large ships, whereas we would be using smaller ships in the St. Lawrence Seaway and Great Lakes. So you could perhaps double that quantity for the marine emissions. But nevertheless, these are very significant possible reductions in the greenhouse gas emissions associated with the freight transport. Over the left here, we have shipping from rail to truck or from truck to rail. And there are some outstanding examples of this in Canada's economy. Generally, major retail chains use this in their continent-wide transportation systems. Canadian Tire, for example, you can see these containers being loaded on trucks from railway, which has brought them across Canada. Very efficient and low emissions. And it's possible to do this with most of our containers coming in from overseas. The Ontario Ministry of Transport Commercial Vehicle Survey shows an astounding tonnage of freight that's traveling along Highway 401 between Montreal and the GTA. And a very large amount of this could be shifted to rail or to even to marine with improvements in infrastructure. Over the right here, we see a ship from Doornkamp Lines. Ben Doornkamp's a pioneer in marine shipping of freight in Ontario from his base in Picton, Ontario. And he thinks that we can ship much more of our freight by ship, perhaps not in the winter, but in the other three seasons at very low cost through the Great Lakes and the St. Lawrence Seaway. What we seriously need to create this infrastructure is cooperation between the various levels of government, industry, other provinces, other states, and even the United States in order to establish a truly efficient freight transportation system involving these three modes of travel. Cooperation is perhaps the most significant need. It's not a question of money, it's unity among the various levels of government and the various states and provinces. Somewhat ominous note here, if we don't improve our freight transportation system in Canada, Canadian shippers will ship through the United States. In November, President Biden signed a $1 trillion bill to improve the transportation system, especially the freight transportation system in the United States. Ports, intermodal terminals, railways, ships, $17 billion for port improvements. And if we don't keep up with this, we will lose this freight transport to the United States. What would be better would be a close cooperation so that throughout North America, freight is delivered efficiently with the minimum greenhouse gas emissions. And we can do it. There are practical, achievable actions and technologies which can be achieved within the next 10 years at acceptable costs. This will be in the billions, but it's much less than the alternatives that have been proposed. It's cost effective. It will show up in better transportation, more efficient, and lower transportation costs overall per ton. And it is acceptable to industry. These recommendations were based on interviews with industry experts who are willing to talk about practical, achievable actions. The other benefits to our transportation system would be relieving overloaded highways. This is a serious consideration in Ontario. I'm sure we've all, at one time or another, been stuck on Highway 401 or on the Queen E with thousands of cars and hundreds of trucks sitting there in a traffic jam. Is there some way we can relieve that without building even more highways? This solution would relieve the shortage of truck drivers. In the trucking industry, we are looking at a very serious shortage of truck drivers. It's the main looming problem for the truck industry. We can also look at better air quality with thousands of diesel engines replaced by a few hundred, and larger diesel engines with air emission control systems. And of course, we will look at a freight system which could compete with the USA, or at least cooperate with the USA. Here, once again, is the record of greenhouse gas emissions from Ontario diesel highway trucks. And we think that we can bring these emissions down to the 2030 target within 10 years if this is done with enthusiasm. Now, let's move on to the more futuristic technologies. Perhaps some people watching this are wondering where are the futuristic technologies. Let's start on those. New technologies, biodiesel fuel. It's fuel that's made from waste biomass like fats and oils. It is already being produced, but a certain rocky start. And there's always the question of whether this biomass should be used for food or for fuel. Renewable natural gas fuel, that's methane from the anaerobic decomposition of biomass. It happens in solid waste landfills and can be put to use to fuel natural gas systems and motor vehicle engines as well. Once again, the question is how much is available and what's the cost? Renewable ethanol and methanol, these are alcohols in diesel fuel. Great deal of debate over the cost and net benefits of ethanol. We're still looking at research for converting waste biomass like straw and leaves to ethanol, and it's still pretty expensive. Methanol is the other alcohol. It can be made from, well, the old wood alcohol process, although we have to wonder just how much greenhouse gas is released during the production of methanol. And it has some effect on diesel fuel, some wariness from the Ontario Trucking Association. Autonomous trucks, these are trucks where computers driving the truck instead of a driver. And there are some driving around Toronto even today, although they have human drivers sitting in the driver's seat in case something goes wrong. And apparently these autonomous trucks drive more efficiently than human drivers. Truck platooning, where 2, 3, 4, 5 trucks are driven close to each other, close behind each other, with improvements in aerodynamic efficiency. This is done in the remote parts of Australia. Some wariness in the Ontario Trucking Association, especially in the winter. And finally, the elephant in the room, electric batteries and hydrogen. And these are futuristic. They cannot be accomplished for 135,000 trucks, let alone 8 million cars in the next 10 years. We need something else to bring those emissions down to the 2030 goal. All of these technologies require research and development and demonstration. They need cooperation between provincial and federal governments, and even other states and the United States government as well. And we need the infrastructure to implement them if they are in fact widespread. For example, hydrogen distribution and filling centers. I'm going to talk about electric batteries and hydrogen to replace diesel fuel. It's, I guess, the elephant in the room, because many people think that's the golden solution to our problems for vehicle emissions. My source of data on the electricity system itself is the Independent Electricity System Operator in Ontario, and you can download its reports from a website. And it gives us an authoritative vision of exactly how many kilowatt hours come from each source of generation. Nuclear, hydraulic, natural gas, wind, solar, it's all there. So this is a calculation of how much electrical energy we would need to power the 135,000 highway trucks in Ontario if we changed from diesel to electric battery or hydrogen. First start with how much fuel they consumed. It's 5.57 billion liters in 2019. And if we calculate the fuel energy for that, it comes out to 213 petajoules. Multiply that by the engine efficiency of a typical truck engine, 0.39, and we come out with 84 petajoules per year of mechanical energy was used by these trucks to drive the wheels. Converted to electricity units, that's 23 kilowatt hours per year of electrical energy. Now that's a lot of electrical energy. It's equivalent to approximately 17% of Ontario's annual electrical energy consumption. Where will we find this new electrical energy? Probably not from the nuclear fleet, which is operating capacity, not from the hydraulic fleet, which is also operating capacity. Wind turbines, great when the wind is blowing, not when the wind is not blowing. Photovoltaic solar electric panels, great when the sun is shining, but not when the sun is not shining. Where will we find this extra 17% of Ontario's annual electrical energy consumption? We'll find it from, unless we build more generation facilities, we will find the electrical energy from our existing natural gas fired generators, which are currently underused and have excess capacity greater than 23 terawatt hours per year. And that's a somewhat sobering idea that we'll be burning fossil fuel to replace fossil fuel. Some people will say, no, let's build our wind turbines to generate this extra electrical energy. How many wind turbines would we need? Over 9,000. And these would cover an enormous land area in that thousands of square kilometers, and it would be located in the windy areas of Ontario. Probably not feasible. How about solar electric photovoltaic modules? 79 million square meters of photovoltaic panels. Also very, very doubtful. Or we could go back to the CANDU nuclear system and build 3 more Bruce-sized CANDU nuclear units. Now, this is rather sobering calculation. You can look at it in the report to see the details of it. So it shows that there are tremendous barriers to overcome if we really do expect to power all these trucks from renewable energy, from batteries and or hydrogen. This does not include the extra energy needed to store energy and reuse it. It does not include the energy of electrolyzing hydrogen or of charging batteries or the extra transmission and distribution. The other possible problem is how on earth are we going to get this power from the generating stations to the trucks? One of the electric truck manufacturers, Volvo, has come up with a new full-size highway battery-powered truck, and it says you can charge this truck from 0 to 100% using 43 kilowatts of AC power over 9.5 hours, or 250 kilowatts of DC power over 2.5 hours. These are really enormous amounts. And imagine building these chargers in thousands of locations in Ontario. Just think of the transmission lines, the distribution lines, and the extra transformers. It doesn't sound like a really plausible idea. Now, I will say one thing, that there seems to be quite a good opportunity for electric delivery trucks within the urban areas where they never stray more than, say, 10 kilometers from their chargers, and they can be charged overnight. And these seem to be developing more and more. On July 13th, Walmart announced in the United States that it will be purchasing 3,500 electric delivery trucks. So that's some word of encouragement. But generally, the bottom line is we need to look at these practical, affordable improvements before we consider changing all of our diesel trucks to electricity. So that is probably the summary for what we can or should do with battery power and hydrogen. So looking at the big picture, the recommendations for governments and industry, the need for action, if we're really concerned about eliminating climate change and reducing our greenhouse gas emissions, we need to act boldly and decisively in the right direction. You often hear the phrase, there is no planet B, or there's no plan B. And that's, I believe, is true. But the corollary to that is we better get it right with planet A. And if we waste our time with exotic technologies and expensive demonstrations and publicity stunts, we will fail. We need simple, practical measures to solve our climate change problems. We need unity among governments and industry. Federal government, the Ontario government, other provinces, the United States government, and states as well. We need unity, for example, setting standards for the devices that would be used to streamline trucks. It needs to be a common North America-wide standard. We need unity to plan an efficient freight transportation system across states and provinces involving intermodal transportation. There are practical, achievable actions and technologies which we can use and should use. There is infrastructure that we need. We need railways, ports, and this can be accomplished. And in the long term, new technologies, let's not rule them out completely, but don't expect them to bring down truck emissions in the next 10 years. Once again, the research report, its title is Reducing Greenhouse Gas Emissions from Ontario Diesel Highway Trucks, and it is available on the OSPE website. If you have any questions or concerns about this ENGtalk, please direct them to me at the email address shown on this video. And you can also see the URL of the report on this video in case you want to download it and look at it or print it. Thank you very much for your time.